In today's video, we'll be creating this particle advection where we have particles flowing through some sort of fluid after an initial burst of energy. We'll be using simulation nodes, so it will use a bit of math, but I'll try and go step by step and explain exactly why we're doing what we're doing so that you can create your own custom animations exactly to your requirements. With that, let's actually begin the tutorial. In our default scene, we're going to actually use the default cube not only as the geometry node object, but as the actual shape, because I want to create the node in such a way that I can apply the same thing to any other object, and whatever object it is can then have the burst of particle energy leaving the surface of the object. So let's bring our cursor to the junction of these two windows, click and drag to create a new window, and then change this from the 3D viewport to the geometry node editor. Then we'll press this plus button to create a new geometry node tree, and then we'll zoom in, and we're actually going to keep the group input as I explained. Now the first thing that I need to do is distribute a bunch of points onto the surface of this object. So for that, I'll press Shift A and search for a distribute points on faces node and plug that in right here. Now the density should be one of the inputs that I can control from the geometry node object itself in the modifier panel over here. So I'll take this density and plug it in to the input like that so that it can be controlled right from out here. For now, I'll keep a density of something like 1000 so that it's very dense. And I'll also change the shape of the default cube by just pressing S, X, and increasing it to maybe 2 units. Now I'll start off with the simulation zone section. So I'll press Shift A and search for a simulation zone. Now everything within the simulation zone is going to repeat on each frame, and whatever is outputted for the geometry will be fed in as the input for the next frame. So let's take this point, plug it into the geometry, and take this output and plug that into the group output. Now on each frame, I want these particles to move according to their velocity. So the first thing that we need to do is give an initial velocity. For the initial velocity, I'll press Shift A and search for a capture attribute, and I'll plug it in here. And because velocity is a vector, which means it can have a value for the direction as well, we have to change this from float to vector. Now I want this velocity to be initially along the normals along with some amount of randomness. So what I'll do is I'll move this to the side and press Shift A and search for a noise texture, which is going to give me a random value from 0 to 1. Now I want this to not only be from 0 to 1, I want it to be in the negative values as well, centered around 0. So I'll press Shift A and search for a vector math node, and I'll change it from add to subtract, and I'll subtract a value of 0.5 on all of the axes. Then I can take this color and plug it into the vector, and this has to be added in to the normal. So let's press Shift A and search for another vector math node. And if you don't understand vector math, check out this video over here, which will give you a really good understanding of this vector math node and how you can use it in various situations. Now we'll take this normal and plug it into the first socket, and we'll take this subtract and plug it into the second socket, and this is what we can plug in as our base velocity. Now because we're using this noise texture that goes only to a value of 0.5 and minus 0.5, I actually want to scale it up using another vector math node. So I'll press Shift D with this vector node selected and change this from subtract to scale. This way I can increase the amount of noise texture at the beginning or decrease it as well. So for now, I'll maybe scale it up by a value of 5 so that the max value at any point of time is 2.5. So now we have the actual initial velocity over here, but it's not being updated to the points at any point of time. So let's take this and plug it into the input of the simulation zone, and then go to this side panel over here, go to the node tab and select the simulation input. Now for the simulation state, you can change this from attribute to velocity. And now you can press Shift A and search for a set position node, plug that in right here, and take the velocity and plug that into the offset. Now this output velocity is what's going to become the new velocity on the next frame, and because the output velocity is 0, 0, 0, it should move only on the first frame, and then the next frame it no longer moves. So obviously that's not what I want. I want it to continue moving in this direction for now. So I'll take this velocity and plug it into the simulation output as well, so that the velocity is the same on every single frame. So let's see what happens when it moves with uniform velocity. So that looks good. It's bursting out in mostly the normal direction with a little bit of randomness added in, which I think looks exactly like what I wanted. So now what we have to do is we have to update the position. So let's go ahead and take the simulation output, move it to the side, and press Shift A and search for another vector math node. And the first thing that I want to do is actually scale down the velocity on each frame. So I'll search for the scale node, and I'll reduce this to maybe a value of 0.8 so that it becomes 80% of its velocity on each frame. So let's play the animation, and now you can see it slows down and stops right about there. So that looks good enough for now, but obviously we don't want it to just stop like that. So we're going to add in some amount of noise, which will help make this particle flow along with the direction. But before we add in that noise to allow it to actually flow, we have to calculate the velocity and make sure that the velocity is updated correctly. Because right now we're just scaling this velocity down by 80%. Instead, what we're going to do is we're going to calculate the new velocity on each frame. So remember, velocity is the change in position divided by the time it took. And since we're updating it every single frame, the time is going to be one frame. So the velocity per frame is calculated just by subtracting the final position minus the initial position. So if we search for a position node, this will give us the position of whatever is connected towards its right, which means every single one of these particles. But we also want the initial position of the particles. So for that, we need to search for another position node and actually capture that position right here before we actually set the position. So let's press Shift A and search for a capture attribute node, plug that in right here and change this from float to vector. Now we're going to take the position and this output is going to be the initial position before we set position. Now to calculate the velocity, we'll press Shift A and search for a vector math node, change it from add to subtract, and we'll subtract the final position minus the initial position which is present over here, and this output is going to be the new velocity. If we directly plug this in here, the velocity is no longer being scaled by 80%. So what we're going to do is, instead of plugging the scale value in here, we're going to take it and plug it in after the subtraction or the calculation of the current velocity. So once it's plugged in over there, we should get a slightly more accurate change in velocity. But to this, we have to add in some amount of noise, which will allow the nice change in flow and directions. So for that, we have to press Shift A and search for another vector math node. And this time we're going to keep it at add itself. So we need to add in some amount of noise. So for that, we'll press Shift A and search for a noise texture. Now again, just like last time, the noise texture is going to go from 0 to 1, but we need it to go from minus 0.5 to plus 0.5. So we'll search for another vector math node and change it from add to subtract. We'll subtract a value of 0.5 on all of the axes and plug this color into the first socket. Now we'll press Shift A and search for another vector math node, which we're going to change to scale so that we can actually control the effect this has. So let's plug it in just like that and keep this at maybe a scale of 0.2 so that it's very less being added into this vector. So let's plug this into the vector, and now we should have some amount of noise being added in as well. The scale of the noise is way too large, but let's actually look at what it looks like before we change it. So right now you can see each of these particles are moving fairly randomly, so it looks very chaotic. So let's change that by reducing this scale down to something like 0.2 and then going back to frame 0 to reset the simulation and playing the animation. So now you can see they formed this really nice pattern after it's completed bursting out. But for me, this entire bursting out is a bit too strong, so it looks a bit too uniform right at the start. At least for the first maybe 10 frames, it's far too uniform. So what I'll do is, for the first 10 frames, I'll change this scale from 0.2 to something like 1.5 so that the effect of the noise texture is very high. I'll hover over it and tap I, and then by around frame 10, I'll reduce this back down to something like 0.2, and then I'll tap I. And in fact, instead of having it on frame 10, I'll have it maybe on frame 15 so that it has some time to actually slow down into the final value of 0.2. So now when I go back to frame 0 to reset the animation and I play the animation, I think that burst looks a lot better because it's uniform only for the first 4 or 5 frames, and then it starts taking on the nice flow patterns. However, the initial velocity is a bit too high for my liking. So over here, I'm actually going to reduce this scale from 5 to something like maybe 2, and then I'll replay the animation. And I think that looks a lot better, but it's a bit too uniform again. So maybe a value of 2.5 or 3. So all of these values have to be played around with quite a bit until you get something that you're absolutely happy with. But I think I'll go with maybe something like this for now. The next thing that we have to do is actually remove particles that are present for longer than a certain amount of time. For that, we need to start calculating the age. So to calculate the age, we first need to capture the age for all of the particles. So let's shift this a bit to the side and then zoom in, select the capture attribute and press Shift D to duplicate it. Now the age is going to be an integer, so we'll change this from vector to integer, and then we'll plug this in right after the first capture attribute. Now the initial age is going to be 0 for all of the particles, so we'll just take this and plug it into another input for the simulation input. Just like last time, we'll select the simulation input, go to the node tab, change the attribute from attribute to age. Now on each frame, we want the age to increase by 1. So let's go ahead and shift these a bit lower, make some more space by maybe moving all of these a bit higher, and then pressing Shift A and searching for a math node. Now we'll take the age and we'll simply add a value of 1 and then plug this value into the group output age over there. So now every single frame, the age gets incremented by 1. Now we need to delete particles that are greater than a certain age. So let's press Shift A and search for a delete geometry node. Now, of course, I can compare this with a single value using a compare node and changing this from float to integer and making sure that this value is greater than maybe let's say 140 and using all of those particles as the selection. But the problem with this is that at frame 140, all of the particles will just die at the exact same time and they just disappear like that. Obviously that does not look realistic and I just want a few particles to start deleting randomly from long before. So what I'm going to do is instead of having 140 as a solid number over there, I'll press Shift A and search for a random value. Now I'll change this from float to integer and I'll make the min value as maybe 110 and maybe the max value will be 148 so that it makes sure that all of the particles are removed before the last frame, which I'm going to keep at around 150 so that it becomes a 5-second long animation. Let's plug this into socket B, go back to frame 0 and play the animation. So that's what we have as of now, and you can see that the number of particles start reducing and they just disappear by frame 150. Now of course I feel like the initial velocity is still a bit too high. Maybe I'll reduce this scale as well down to 3 and then just restart the simulation, and yeah, that looks good, but maybe this velocity is also being attenuated a bit too fast. So let's make this 0.95 instead of 0.8, and that was a bit too strong. So maybe 0.9, and just play around with the values until you get something that you're absolutely happy with. Once you're happy with the way it looks, you can go ahead and complete the node tree by pressing Shift A and searching for an instance on points, because right now they're all points, and if you're rendering it out in Eevee and you switch over to your rendered view and just switch off overlays, none of the particles will be seen. So to actually make sure that the particles are seen, we have to instance something on each of these points. So for the instance object, I'm going to search for an icosphere and I'm going to reduce the radius to something really small. Let's go with 0.01 and maybe increase the subdivisions just to a level of 2 and plug the mesh into the instance. Now that looks fine, but there's a few more things that we have to do. The first is capturing the age so that we can use it in the shader editor. So I'll press Shift A and search for a store named attribute and I'll plug it in right here, and I'll take the age and plug that in over here. But again, I don't want it to be a floating point number. I need it to be an integer. So I'll take the age and plug it in here and name the attribute as age. Then I also need to set material. So I'll press Shift A and search for a set material. I'll plug it in here and I'll choose the default material. Now, apart from the age, you could be using the velocity as well. Maybe I'll use that. So I'll store in the velocity as well by duplicating the store named attribute. And this time I'm going to change it from integer to vector, and I'll take this velocity and plug it in right about there. So that way I can have fast moving particles as one color and slower moving particles as another. Now that you're done with all of these, you can go ahead and actually fix the group input so that you can make changes right from here instead of having to go in and change these values separately. So a few of the things that I want to have control over is the actual shape that these particles take while flowing. So for that, I'm going to go ahead and take this scale from the noise texture and plug it into the group input. Similarly, I'll do the same for the detail, roughness, and maybe distortion. Then I need some control over the initial velocity. So I'll take this scale value over here, plug that in. And again, to make sure that I don't get confused, I'll have this group selected, go to group and change the name over here. So I'm going to change this scale to maybe noise scale. Detail can be noise detail. Roughness can be noise roughness. Then for the scale over here, it's the actual velocity. So I'll rename this to initial velocity. And similarly, I want to be able to control the lifetime when all of them die. So I'll take the min and max and plug those in as well. So let's take this, plug it in here, take this and plug it in there. And of course, rename these to min life and max life. Similarly, other aspects can be taken in right over there so that they can be controlled from here. But for now, I think that much is enough for the geometry node section. But one last thing that I want to do is, if we actually take a look at this, these lines actually stay fairly constant after a certain amount of time. So as you can see, these lines are formed and they stay exactly like that and they don't change over time. So I want these to change over time and not become set just like they are being set right now. For that, I have to change this noise texture from 3D to 4D, and I have to change this W over time. So I can either add in a driver, or since I'm using geometry nodes, I'll just search for a scene time node and I'll take the seconds and divide it by a certain number. So I'll search for a math node and change it to divide, and then plug the seconds into the first socket, maybe divide the seconds by 50 and plug this value into the W. So that way over time, the W is going to change, and so these lines will also change. So if we go back to frame 0 and play the animation again, you can see that at no point of time is the line going to stay and remain. So right now you can see that there is a line over here, but but over time, in the next few frames, the line slowly changes its shape. Now, if you feel like it's not changing its shape enough, you can always go ahead and reduce this value, maybe make it 10, and now whatever lines are formed are going to change even faster than they were changing before. So clearly you can see the shape of the line is continuously changing over time, and I had to divide it by a value of 0.5, which means I'm multiplying it by a value of 2 to get it to change. Now, if you change the frame rate, it's going to be completely different. So that's why I use seconds itself instead of frames. So I think that looks much better. The lines are continuously changing shape as well. And with that, we can actually start off the texturing section. So we'll change from the geometry node editor to the shader editor, and we'll switch our viewport shading to rendered. Then we'll delete the default light, or we'll just hide it for the time being. Now we'll press Shift A and search for an attribute node, because we stored both the age of the particles as well as the velocity of the particles in two different attributes. If you want to see the changes, make sure that your viewport shading is changed to rendered. Now we'll change from geometry to instancer, because remember, we want the material to be added into the particles which have spheres instanced on them. So let's change this to instancer and choose the name as age, which actually reminds me that in the geometry node section, when we capture the attribute, we should be capturing it not for every point, but we should be capturing it for every instance. So the store named attribute has to be changed from point to instance. Now let's go back to the shader editor, and let's take the age and plug that into maybe the emission strength. So now let's press Shift A and search for a math node, and we'll change this from add to divide so that we can divide some value by the age. So right at the beginning, when the age is small, the emission strength will be very high, but as the age increases, the emission strength will slowly decrease. So let's change the emission color from black to maybe a white, just like that. And instead of 0.5, we'll make this a higher value. Let's go with 1000 or maybe 150. Apart from that, because the age was an integer, we shouldn't be using the color. We should be using the factor from here. Now, for some reason, I'm seeing these black particles. So we have to figure out exactly what's happening, because the age should be black only if this divide output is 0. So it can't be 0, because as long as we're dividing some number by some other number, no matter how large this value is or how small this value is, this output is not going to be 0. So something must be wrong. Let's go see what we did in the geometry node editor. And you can see in the store named attribute, we've stored even the velocity as age itself. So we have to make sure that we change this from age to something like velocity. So now we have the velocity stored in an attribute called velocity, and the age stored in a velocity named age. Now let's go back to the shader editor, and we'll switch on all of our render defaults. So we'll switch on bloom, and then we'll go to our world settings and change the background all the way to black. So now let's take our camera and press Alt G to clear location, Alt R to clear rotation, followed by RX90 to rotate it on the x-axis by 90 degrees. Then we'll press 0 to go into our camera view, and we'll press GY to just bring it back to view all of our particles. Now, since we're using the default cube, of course, that doesn't look too great right at the start, but the main idea is that you don't have to use the default cube. You can apply this geometry node tree to any shape that you want. For example, we can go ahead and disable this cube by just enabling this option as well, and then switching it off over here so that it no longer slows down our viewport either. Then we can press Shift A and search for maybe a mesh torus. To see the torus, let's just change our viewports, and then let's rotate it on the x-axis by 90 degrees, scale it up by a bit, maybe add in a subdivision surface of level 2, and then in the modifiers, let's just add in a modifier which is going to be the geometry node modifier, but then we'll choose the geometry node over there. Now, when we go back to frame 0 and we play the animation, you can see we get a completely different look for the torus. Now, I think the density for this has to be increased by a lot. And if you actually look at this growth, it looks really, really cool. Now, I think that the initial velocity is also a bit too large. So let's change that to maybe 0.5. And that looks like a really cool particle advection. The last thing that I wanted was to have the color based on the velocity. So let's just go ahead and do that as well. So what we'll do is for the actual emission color, we'll press Shift A and search for another attribute node. This time it's going to be again the instancer, but it's going to be velocity, so VEL. Then we can press Shift A and search for another math node so that we can divide the velocity by whatever number is necessary to bring this into a range of 0 to 1. We could have used map range as well, but we don't know what the max velocity is. So just changing by dividing the actual vector with different numbers will help us calculate that faster. Then let's search for a color ramp node and change the colors from maybe this black to, let's have the slowest particles be blue, maybe something like that, and the fastest particles could be maybe this sort of a bright blue. So we can now plug this into the factor and plug this color into the emission. So now you can see right on frame 1, all of them are fairly fast. And just to help see this better, we'll just change this to a contrasting color for now. Let's say the fastest particles are going to be red. So now if you divide by larger values, you should be able to see both the red and the blue particles come in. So okay, let's go with a value of 0.3. So now the fast moving particles are are going to be red and the others are going to be blue. But right now you see, even in the fast moving particles, only particles that are going towards the top right are red and the bottom left are blue. That's because velocity was a vector, and since we're taking the factor, it's just considering the position of the vector. So anything that's pointed in the first quadrant will be red and anything towards the third quadrant will be blue. So we'll change that by searching for a vector math node, changing it from add to length, taking the velocity and plugging that into the vector, and taking this output and plugging that into the value. Now everything is super fast at the start, so it all starts off red and then it slowly transitions from the red to the blue. Now maybe this value is a bit too small right now, so let's increase it, and now we should have a nice red to blue transition, which I think looks really cool. Now of course you can play around with these settings a lot more. You could maybe make a plane so that it all goes upwards, just like a burst of energy from the bottom of the screen, or maybe from the sides of the screen as well. It's really up to you, and you can have fun playing around with the different ways in which you want to create the actual particle advection. If you're happy with the way everything looks, you can go ahead and press render animation. I hope this was a very useful tutorial that you can use in multiple different ways. Whether it's music visualizers or just backgrounds or just sci-fi animations, the fact that you can store this geometry node as an asset and reuse it in other videos makes it very, very powerful. If you liked this one, definitely check out other videos on my channel because I post videos every single day. So there's definitely something or the other waiting for you to discover it. Until my next video comes out tomorrow, once again, thank you so much for watching. Keep creating and don't forget to stay creative.